Welcome to the ET420 PIC Mechatronics board, segmented LCD lab demo, part A. Here I'm showing our PIC Mechatronics board and our basic connections. Here's our ICD3 puck and our phone cable and our USB cable back to our computer, same as our LabX board. Here's our LCD display, which we'll be looking at. Here's our power supply. It's going to need the power supply, same one that we're using on the 877. On here we have a DC motor. This one up here is a bipolar stepper motor, and down here is an optical interrupter, which we could use to measure the motors. We'll be using those later. Here is our PIC 16F917 microcontroller right here, and those are the basic connections for us to start. As you'll notice here, we have connections around our microprocessor, which are male headers, and we'll be using our special jumper wires when we need them. And our switches are over here, and we're going to use this header here. Here's a little closer view of our Mechatronics board. And here we have two potentiometers, which will feed into our A to D converters. We have a reset switch, and then we have three switches, which we'll use later in this lab. And these switches need to be hooked back to our microprocessor. And don't use this. This is for a little smaller microcontroller, which we'll possibly use. This is our motor current over current sense. So here's our reset button. So once we plug this in, we will probably get an amber LED. Just push the button. It won't affect anything because we're not using the motors in this lab. And that's pretty much it. On this board, we're using liquid crystal displays, LCDs, but they follow the same 7-segment pattern of LEDs. So this is our patterns that we're going to use for 0 to 9. These are the segments in order to represent our hexadecimal numbers. Okay, the first thing we need to do is go into Canvas and find our PIC LCD folder with our files on it, and then drag it to the desktop or somewhere where you could find it. Those will be all of our files. Next thing we need to do is open up our MPLAB X IDE. Okay, I have my microchip MPLAB X IDE open, and we're going to make a new file, new project, sorry. And we're going to go microchip embedded, standalone project, next. We're going to go to families, and we're going to go down to mid-range 8-bit MCUs. And we're going to go all the way down to PIC 16F917. Okay, PIC 16F917. Next. And we're going to choose our ICD3 and our XC8, and we're going to point back to our folder that we just put on the desktop, and we're going to call the first one PIC C, let's underscore C LCD1. How about that? Finish. And let's open it up and go to projects, and we want to go down to source files. Right click on source files, add existing item, and we're going to go back to our folder, and we're going to grab PIC LCD1. Select and double click on it, and we could open it up. Okay, let's go through it right now. This is our first file, And we have our configuration. This is going to be different than our 877. So these are the configuration bits for the 917. We're going to use our include XCH. And let's see here. And this is our main. And these are the segments. And this is a straightforward program. So what we're going to do is on our A bit, it looks like we're going to have all 7 of the LCDs lit. So it should say 8. We're going to get the digit 1. Okay, so this guy's only the digit 1. So once he's on, there's just a 1. And then we're going to be doing ohm and volts and our second decimal point. And don't worry about the errors. And this is all code in order to initialize our LCD driver. And that looks good. Okay, let's compile and program our board. And we're going to pick my ICD3. And let's take a look at the board. So here is the result of our basic program, and it's correct. Okay, I'm back to the MP lab, and here I've defined each of the 7 segments. This would be segment 1, which would be the far right, and this is setting the internal drivers for our LCD. And A and B and C, those are the segments of our 7 segment. So this would be our digit 2, this is our digit 3, and this would be for our digit 4. Okay, and these are defining which segment lights up our different icons. So let's go down to here, and we want 6.2. So 1 would be the far one over, and we're going to need to make that 2. So let's go ahead and copy and paste this so we can get our second one. Copy, paste, and let's put him down where he belongs. And we're going to erase this one because we're not going to use that 4th digit. We're going to use ohms, and we need to use K. So let's find our K. K would be SK. So if we go copy paste, and we're going to go ahead and just put it right here. Doesn't matter which ones. And SK is going to equal 1. Semicolon. And let's just go ahead and copy and paste our text here, our comment. And that's going to be little k. Okay, and we're not going to use S. So we could comment that out or erase it. And here's our second decimal point between 1 and 2. That sounds good. All right, so let's make this 2. It's going to be our second digit. And we could change our comment if we want. Okay, so let's go ahead and go check our chart and see what we need here. Okay, here's our chart. So 6, we want 6.2, so it looks like everything's going to be on, so 1s are on. and B is an off. So we need to turn B to 0 in order to turn it off. Okay, so here's our second digit, and it's going to actually be our first digit because it's on the left, and we need to convert B to 0, and that should be our 6. So let's go back and check for 2. Okay, for digit 2, we're going to turn off F and C. So let's go ahead and do that. Okay, we're back up to our first digit, which is going to be our far right, and we need to turn off C and F. And let's go ahead and compile it and see what we get. Here is the result of our modified program, 6.2 k ohms, and it's correct.